the remaining types, that is we have finished the first two types, that is a positive catalysis, a negative catalysis. We are going to proceed with the third type, is known as the autocatalysis, where the word itself suggests that these reactions are self-catalyzed. So when certain substances which are self-catalyzed are known as auto. So auto means self. Now there are certain reactions in which one of the product of the reaction has a catalytic effect on the reaction itself. For example, if we carry out a particular reaction where the reactants are A plus B, in presence of a catalyst C, in absence of any catalyst, they can form the product as a DEF. So in this particular reaction, either the product D or the product E or the product F, that can play a self-catalyzing role. That means either D, this can act as an autocatalyst, or E or F. So in some of the reaction, one of the product of the reaction has a catalytic effect on the reaction itself. The reaction is very slow at the beginning of the reaction, but the reaction is faster at its latter stage due to formation of a autocatalyst during the course of a reaction. In this regard, I would like to give you one very simple reaction, that is this titration that we have conducted from our BSc1 level. We know we have carried out the titration of potassium permanganate with oxalic acid. In this titration, we have taken potassium permanganate in a burette, while oxalic acid that is taken in a conical flask. And to this conical flask, we have added about 1.5 taste of sulfuric acid, and this reaction mixture is heated to about 70 degrees centigrade. And after attaining 70 degrees centigrade temperature, by this reaction mixture, we have added potassium permanganate from the burette. So, what is the reaction? We have added from burette potassium permanganate, which is intensely purple in color, this in presence of sulfuric acid, this potassium permanganate, that is twice KMnO4 plus thrice H2SO4, that we have added around 1.5 test tube of this sulfuric acid. Here, this reaction mixture is to be heated around 70 degrees centigrade, approximately 70 degrees centigrade. It can form the products as like this: K2SO4, that is a potassium sulfate, plus twice MnSO4 plus thrice H2O plus 5O. This is the normal course of the reaction. So 4 byproducts have been obtained during the course of a reaction. Now, as per our definition, that in this case, in the course of this reaction, either this product or this product or this or this, they may catalyze the reaction, that is a autocatalyst. In this case, the formation of MnSO4 that acts as an autocatalyst. So initially, before the formation of this substance as an autocatalyst, the reaction was very slow. But as the reaction proceeds further, so the Mn plus 2 ions, they combine with the SO4 ions from sulfuric acid so as to form MnSO4, which act as an autocatalyst. Now, this is the first step of the reaction. Now, the nascent oxygen which is formed during this reaction, this nascent oxygen now forms another product, that is the oxidation of this oxalic acid takes place, that is that can form 5H2O plus 10CO2. That means here this potassium permanganate acts as an oxidizing agent, while oxalic acid acts as a reducing agent. Now we know that this is a oxidation reduction reaction. That means here the oxidizing agent itself gets reduced. So oxidizing agent gets reduced while the agent that gets oxidized carbon dioxide. In this case, now this is a simple oxidation reduction reaction where the oxidizing agent itself gets reduced while the reducing agent gets oxidized. Now here the reducing agent to get oxidized. In this oxidation of oxalate into carbon dioxide, this manganese sulfate that is formed during the course of a reaction that plays a very important role, that MnSO4 act as a autocatalyst which can catalyze the oxidation of oxalate into carbon dioxide. So this is how the oxidation reaction takes place. So autocatalysis or autocatalysis is nothing but in this type of reaction, one of the product of the reaction has a catalytic effect on the reaction itself. The reaction is faster at its later stage. This is because the formation of a autocatalyst during the course of a reaction. So this is how the autocatalysis that is play a very important role. Then the fourth type is known as acid-base catalysis. Now the name itself suggests that acid-base catalysis where those reactions which are speeded up by acid are known as acid catalyzed reaction, and those reactions which are speeded up by base are known as base catalyzed reaction. For example, if you look at one reaction that perhaps you might have studied, that is C12H22O11. This is known as the cane sugar. This cane sugar, that is inversion of cane sugar, that is possible only in presence of acid. So it can form C6 in presence of water, C6H12O6 plus C6H12O6. The first product is known as glucose, another product is known as fructose. So this inversion of cane sugar that is possible only in presence of only acid, and hence this is known as the acid catalyzed reaction where the dilute mineral acid, for example HCl, that plays a very important role. Another reaction can also be given as, this is first reaction, second reaction, that is conversion of nitrile into amide and the conversion of amide into ammonium salt. This is also another reaction where simultaneous acid and alkali, that is a base, is used to convert this nitrile to amide and to ammonium salt. Now, the conversion of nitrile to amide and then to ammonium salt, this is the best known example of the acid-base catalysis. For example, RCN in presence of water, this is known as a nitrile. In presence of the acid, for example HCl, which is also known as a dilute mineral acid, which can form amide RCONH2. This is known as a amide. So conversion of nitrile to amide, that is possible in presence of this acid. Now the second step is a conversion of amide into ammonium salt in presence of base or alkali. That means this is already formed product RCONH2 in presence of water, in presence of catalyst, say as NaOH or KOH, which is alkali, it can form RCOONH4. So this is amide to ammonium salt. This is possible in presence of alkali. So the conversion of nitrile to ammonium salt in presence of first step is acid, another step is alkali, that is known as acid base catalyzed reaction. So those reactions which are catalyzed by acid are known as acid catalyzed reaction, and those reactions which are catalyzed by base are known as a base catalyzed reaction. Now the fifth type, that is known as the enzyme type of catalysis. Now, the word itself suggests that these are the reactions which are speeded up by the enzymes. We know that in our body or in animals or in plants, large number of enzymes are present. The reactions which are taking place in animals, plants or in human being, those reactions are possible only in presence of certain enzymes which are already present. So these enzymes, they can brought about the chemical change. So the chemical change that is brought about in presence of all such enzymes is known as the enzyme catalyzed reaction. We know that the that farmers normally supply urea so as to have food giving plants where the soil is deprived of nitrogen. So whenever a particular soil that is having scarcity of nitrogen, urea is added, and urea is having the formula as CONH2 twice. This is also known as a carbamide or urea. Then farmers supply plenty of water so as to dissolve this urea, and when this urea start to dissolve, then the products ammonia and carbon dioxide that is formed. Now the formation of ammonia and carbon dioxide from this urea is possible only in presence of certain enzymes known as urease. So perhaps you might be knowing, whenever a particular word that ends with ASE, particular B group students, botany zoology students, they might be knowing that when a particular word that ends with ASE, it is definitely an enzyme. So the urease, that enzyme that is already present in the soil, can bring about this chemical change. So from this ammonia, that is NH3, nitrogen is easily assimilated by the roots of the plants, which is made available to the food giving plants. So this is first example under the enzyme catalysis. Second example, that is C6H12O6. This is known as the glucose. This glucose is converted into alcohol, that is ethyl alcohol, like this chemical reaction. The glucose is converted into ethyl alcohol and carbon dioxide. This conversion is possible in presence of an enzyme, that is zymase. So zymase is an enzyme which brings about the chemical change of glucose into ethyl alcohol. So this reaction is also included under the enzyme type of catalysis. And the sixth type, that is known as the induced type of catalysis. Sixth type is known as induced catalysis. So the induced catalysis is nothing but, in certain reactions, the substance which induces another reaction to proceed further. All such substances which are responsible to induce the reaction are known as induced catalytic reaction. For example, a very simple reaction I would like to give here is this is known as Na2SO3. This is known as sodium sulfite. In presence of atmospheric air, this sodium sulfite is converted into Na2SO4. This is known as sodium sulfate. Mind well, there is much more difference in the sulfite which contains SO3 and sodium sulfate. It is oxidized product, that is sodium sulfate. This is possible in presence of air. Now another reaction if we want to carry out, then this reaction is Na3AsO3. This is known as sodium arsenite. In presence of atmospheric air, if we want to convert this sodium arsenite into Na3AsO4, this is known as sodium arsenate. So there is a difference between arsenite and arsenate, similar to that of sulfide and sulfate. Here initially there is a difference of only one oxygen, ITE less oxygen, ATE one oxygen is more. Arsenite one oxygen is less, that means Na3AsO3, one oxygen is more, Na3AsO4 sodium arsenate. So this is sodium arsenite and this is arsenate. Now our aim is to oxidize sodium sulfite into sulfate and sodium arsenite into sodium arsenate. Now as our aim is to oxidize both these reactants into their oxidized products, then if we mix Na2SO3 and Na3AsO3, if we prepare a mixture out of the mixing sodium sulfide and sodium arsenide, then both these reactants, they are converted into their products as Na2SO4 and this is oxidized into Na3AsO4. So here the presence of Na2SO3 that acts as a induced catalyst. In this case, just by mere presence of this substance, the reaction is carried out. That means both get simultaneously oxidized into sodium sulfate and sodium arsenite. So here this reaction is known as induced catalytic type of reaction, where certain reactions which induces another reaction to proceed further or to proceed rapidly is known as induced catalytic type of reaction. So this is how we have finished the 6 different types under the types of catalysis. So once again you should remember that is much more difference in the classification and the types of catalysis. The classification is a homogeneous and heterogeneous, and the types of catalysis are the positive, negative, auto, acid base and enzyme type of catalysis. So this is how we have finished. So once again you should remember or you should bear in mind that whenever the word catalysis that comes, then you should remember that it is definitely a scientist that is responsible to form this phenomenon of catalysis. Now we shall begin with the seminars. I think Disha Patil is ready. Disha Patil, are you ready? Disha Patil.
Yes, sir.
वीडियो ऑन करें. दिशा पाटील, एक मिनिट आहे, मी जे तू पाठवलेलं आहेस ते थोडंसं शेअर करणार आहे. Just a minute. For a few seconds I am leaving the meeting so that I will share your screen